Hey everyone, we've actually seen the most important forces so far, and what I want to talk about in this video is actually a force that I would not recommend, but that seems so obvious and so helpful that I want to put in a video to kind of warn of it, because I used it when I started with Houdini and then quickly realized it's actually not very useful, and that is the pop cone force. So what I have here is just a grid setup to show the problem better, and I actually mixed two things. I mixed the initial geometry, so I created some points in the second input and just a simple grid in the first input, and then I used the grid in the pop source, so there are constantly new points emitted, but the scattered points in the initial geometry in the pop object, so that I already have a couple of points in the beginning. So what we want to look at is the pop fan cone, or just pop fan, call it what you want, and like the name suggests, it's a fan, so it's kind of easy to understand if you play around with it. If you put it like here with the cone upwards and you press start, you can see the points are moved away from the cone. You can of course rotate that thing and move it around, and it seems like a very kind of almost important node to have, because this kind of behavior seems to be pretty common. But it actually isn't, because in reality the big problem here is exactly this cone. Let's first look at the settings. We can increase the wind speed, which is the strength. And when we have wind in the name, it also suggests that the speed of the points will, clamp at some point. So it will never be faster than this wind speed here. And the air resistance defines how quickly it will reach that. And then of course you can change the cone angle, obviously. So you can make the cone much smaller, or you can make it much bigger. And that's pretty straightforward. Now, the big problem is, again, when you look at the actual direction of the points, they are always going away from the center point of this pop fan cone. And there's actually no way of changing this. You have the settings here in the beginning, and then some bindings and inputs, doesn't matter. So there's no way of changing this. So let's say you had something like an actual fan in reality, you would notice that the air is not actually going like this in a perfect cone. If you wanted to cover a certain area, there is no other way than increasing this cone angle though. And let's say you start with this angle. You can see obviously the cone is pretty small, and here the problem isn't that obvious, but let's say you wanted to cover a bigger area. What happens is the points are not moved in the general direction of the cone, but always perfectly in the angle that defines the maximum angle of the cone. And this is very unrealistic, very hard to control, and usually actually not what you want. What you often want is an actual directionality and not an actual cone direction. And this is why the cone fan is, in practical terms, actually surprisingly unusable. I started looking into it once as a beginner, quickly realized that it's really hard to control because you cannot get rid of this effect, and then never used it again in years. So this is why I want to save you basically a bit of time by explaining this to you early on. So what are the alternatives? Well, actually, even though it might be a bit weird, you could, for example, use a pop axis force, because the advantage of the pop axis force is that you can define here a height, let's say, and of course a direction. So maybe something like this, and maybe make the radius a bit bigger. And instead of using the orbit speed, you simply use the lift speed. And what you will see is that the points are, moving in this direction. They do not, fan out. They move in a certain area, but forward from that. And this is actually how a fan, well, more or less, actually works. Let's increase the speed actually. And this is one option of doing this. And as you can see, this gives you way more control. And again, imagine a fan. It's much closer to how a fan actually acts. A pop curve force would do the same. And what you could also do, and we will look at this in a later video, you could actually use any kind of force, for example, a normal pop wind, let's say, to be closer to the pop fan cone, because that is a wind force as well. And you define a certain direction, let's say negative x, which is to the left of us. So let's say -3 in x. And when I press start, you can see all the points are moving to the left. And what we can now do is we can limit this to a certain area. And for this, we will see we can use a pop group by enabling the bounding area. And then we can very specifically define in what area this force should be applied. oh, actually the pop group has to come before. And we give that group the name box1, I don't know, and then we use it here. So I, already showed you now how the pop group works, but there will be a video about this. And here you can see now, we can define in which exact area this force should be applied now. There's another option actually later on, and this is probably the one that I would use, and that is velocity fields. Remember, velocity fields are, volumes that define a direction, and this is way more complicated, but there will be a video in the advanced section of the pop chapter where I show you that you can create those volumes to define any direction anywhere in space that you want. So you're completely free to define anything you want, and this would be an alternative as well, but we haven't looked into this yet, so this is just, in theory. So as you can see, while the pop fan cone force might seem like a very intuitively right approach to everything that is fan-like, like an engine or something, but actually surprisingly, because of the cone concept here, it's actually not very practical. In reality, almost no force behaves like that, and you cannot change this cone-like behavior. If you look at an actual fan, it's way more directional, and we've seen a couple of alternatives for that, and this is why you will probably not use the pop fan much, and I wanted to save you a little bit of time. So I hope this is helpful and made a bit of sense. Thanks very much, and see you later. Cheers.